So let's do the next 5 sums for JEE exam from laws of motion. A small mass of 10 kg lies in the hemispherical bowl of radius 0.5 meters. The radius of this is 0.5 meters. It is revolving around in a circular orbit. Now, along the circumference of the circular bowl on the hemispherical bowl at a height of 0.1 meter, and you know the radius, the whole radius is 0.5, so this part is 0.4. A small mass of 10 grams lies in a hemispherical bowl of radius 0.5 meter at a height 0.1 meter from the bottom of the bowl. Yes, the mass will be in equilibrium if the ball rotates at an angular speed. The ball rotates at an angular speed. Okay, let's see. So then there is a body here whose is given that it's 10 grams. Okay, so if it's 10 grams, then the mg will be acting downward. Yeah, and in this sum you should understand that this is the radius. Can you see this is the radius? I will draw this. The angle that this bob, the metal ball or whatever makes with the vertical is theta, then obviously this will be theta. Yeah, and the normal reaction is along this direction. Yes, because the particle is here, the normal reaction is like this. And since this is theta, this will be r cos theta and this will be r sin theta. And as usual, r sin theta is going to attribute to mv square by r, which is centripetal force, or mr omega square in terms of angular velocity, because mv square by r only is v is equal to r omega, so it becomes mr omega square, as you know, and r cos theta itself is equal to mg, correct? So when you divide this and this, as usual, you get r and r get cancelled. Tan theta is equal to mr omega square by mg, so r omega square by mg g. So suppose this is tan theta. If you can find tan theta, let's see if you can find tan theta. Can you see from this diagram that this is 0.4, this is 0.4, which means this is also 0.4. If this is 0.4 and the radius is the radius here is 0.5. Can you see this radius is 0.5? So we can find this distance, which is root of 0.5 the whole square minus 0.4 the whole square. So you get that to be 0.3 when you solve. So thus you get this distance, that is, can you see this distance alone is 0.3. So why did I do that? Because I want to find what is tan theta. Tan theta will be 0.3 opposite by adjacent 0.3 by 0.4 is equal to r omega square by g. Small r is the radius of the rotation, and r omega square by g, r omega square by g, yeah, is tan theta. Okay, so r is also 0.3, right? Can you see the radius of this circular orbit, you know, the rotation, that is r, which will also be 0.3. So don't you think that this r and 0.3 will get cancelled? Yeah, so omega square into 0.4 is equal to g, which is 10. So omega square is equal to 10 by 0.4, or it's 100 by 4. So omega square will be 25, and so omega will be 5 radians per second. So I hope you all understood. I did 0.3. I could have written here 0.3, I could have kept it as r. Anyway, it's going to get cancelled. So basically omega square is g by this adjacent side, correct? Okay, anyway, so that's the first sum. Omega is radians per second. Okay, next sum is the seventh sum. Okay, seventh sum, if you see, it's a pendulum sum where you have two pulleys and a mass m and m on either sides and a root to m at the center. The theta has been given there, a semi-vertical angle, and you know that when there's a mass like this and a mass like this and a pulley here and a mass like this and a pulley here and a mass like this, and they're saying it's in equilibrium. So you know this is theta. So obviously there will be tension in the string. This tension T will be equal to this tension, and this tension T will be equal to this tension. And can I say this will be T cos theta plus T cos theta, so 2T cos theta on this side. Whether you take this triangle or this triangle, you add up, you get the two adjacent components added up, which is 2T cos theta, which will be equal to root 2 mg, correct? So you know 2T cos theta is equal to root 2 mg. And come here to this part. T, this system is in equilibrium. They have said in the question equilibrium. So T is equal to mg. So then instead of T you can write 2 mg into cos theta is equal to root 2 mg. So mg get cancelled, and this get cancelled. Cos theta is equal to 1 by root 2. So then therefore I can say theta is 45 degree. So what should be the value of theta? Yeah, we have found the value of theta. Okay, let's go to next sum. So next sum is the 8th question. What is the maximum value of force such that the block does not move? This block should not move, which means applied force, that's applied in this direction. Okay, it should not exceed the frictional force. So if you're going to, there will be a horizontal component, and have they given the angle? They given it to be 60 degrees. So it F cos 60 is in this direction, F sin 60 is in this direction, the mg is in this direction, the normal reaction is in this direction. Yes, and they have given coefficient of friction mu is equal to 1 by 2 root 3 or something in the diagram. Yeah. So what do you know? If you go in this component, horizontal component, should not exceed the frictional force which is in the opposite direction. It should not exceed. So F cos theta has to be compulsorily lesser than the frictional force. What is frictional force? Frictional force itself is mu into normal reaction or normal reaction R. And what is R according to the diagram is mu into normal reaction is F sin theta plus mg. Correct, F sin theta plus mg, yes. Mu itself is 1 by 2 root 3. So F cos theta should be less than 1 by 2 root 3 into F sin theta. You know theta is 60. Yeah, what is sin 60? Sin 60, F sin 60. Sin 60 is root 3 by 2, is it? Okay. So F into root 3 by 2 plus mg. mg. M itself is given as root 3 into g, because mass has been specified as root 3 kgs. It's given in the diagram. So when you say that, you can take the root 3 and completely cancel with root 3. So F cos theta is lesser than root 3 completely get cancelled, is 1 by 2 into F by 2 plus g. Yeah, and F cos theta, cos 60, this is second cos 60, F into what is cos 60? 1 by 2, F by 2 has to be lesser than F by 4 plus g by 2, correct? And taking this to this side, F by 2 minus F by 4 is equal to g by 2. On taking LCM, 2F minus F is F by 4 is equal to g by 2, and this get cancelled. If you're going to substitute g as 10 or 9.4, 9.8 depending on whatever you're doing, I'm doing it as 10, so it will be 20 newtons. So that is the maximum force that you can apply so that it does not exceed the frictional force and the body will not move. Okay, let's go to ninth sum. Ninth sum, you have a 1 kg block and a 2 kg block, both of which are moving with a velocity of 2 meter per second and 8 meter per second respectively. So there is a 1 kg block which is moving with a 2 meter per second. There is a 2 kg block which is moving with 8 meter per second. And there is a coefficient of friction which is 0.4 which exists between the blocks. They have given some 4 newtons here, which means a 4 newton is getting dragged in this direction. Whether there's, what is the question? Is it moving on a frictionless surface or it's moving on a surface with friction? Obviously it's moving on a frictionless surface, because they haven't mentioned anything about the coefficient of friction on the surface. It's only coefficient of friction exists only between the two blocks. So find the time when the relative velocity between them will stop. See, whenever they ask you about such questions about relative velocity will come to stop, you can do it using momentum. Initial momentum should be equal to final momentum, correct? So P final should be equal to P initial. Why am I saying this? When will the relative velocity between two blocks stop? When they both are moving with the same velocity. So relative velocity is velocity of A block minus B block, or B block minus B. This has to be 0. VA minus VB or VB minus VA has to be 0. Then they both have to move with the same velocity. So then there has to be one velocity in the final velocity, which is V, which is 3. The entire block's mass 1 plus 2, 3 into V should be equal to the respective masses and the velocities, which is 2 into 8 plus 1 into 2. So 3 into V is equal to 16 plus 2. So 3V is equal to 18. So V is equal to 6 meter per second. That's nice. So you get the velocity. That's the velocity of both the blocks. So now take the first block. You know the velocity of the first block is now V 6. What is the initial velocity? 6 meter per second. So with that they are asking you to find the time taken. So you write V is equal to U plus 80. This is of the top block. Okay, so let's find out what is this. 6. Initial velocity is 2. Plus they are asking for the time taken. Do you know the acceleration? You do not know, but you know the coefficient of friction. I have taught you mu is equal to A into G. So A is equal to mu by G. A is equal to mu into G, sorry. I have taught you A is equal to mu into G. So A is equal to mu into G. So what do you do? So mu is 0.4 into 10. So 4 meter per second. This is only for the top block because that is the maximum acceleration it can have, so that it does not slide over the block 2 kg block. So that is the maximum acceleration when they give you coefficient of friction, so that it will not slide over the block, correct? So that 4 meter per second, they are moving as 1 unit because the relative velocity is going to be 0, which means they are going to move as 1 unit. So then therefore the acceleration top block can be simply taken as 4 into t, with which you can find what is t, and the t has to be calculated as 1 second. So that is over. So once that is done, they are asking about find the time. So then that is all. To acquire 6 meter per second, the time taken is 1 second. Okay. Now find the what's the next part of the question? Okay, find the common velocities. Yes, we found that as a first step. Displacement of the 1 kg in 2 places. Okay, you know the time now. To find the displacement, you can use S is equal to ut plus half at square. Ut plus half at square, because you know the acceleration of the first block, which is 4. You know the time taken by the first block, which is just 1 second, into half, plus you know the u, initial velocity of the first block, which is 2, and you know the time taken is again 1. So with which you can find S.
I think so, yeah.
2 plus 2. So 4 meters the distance travelled by the first block, top block. Because you know the acceleration of the top block using coefficient of friction, you just did A is equal to mu into G. Why you could do that? Because both of them are going to move as 1 unit if the relative velocity is 0. So therefore you could use that A is equal to mu into G. What about the displacement of the bottom block? You need the acceleration of the bottom block. How do you find the acceleration of the bottom block? Acceleration of the bottom block is nothing but total net force by total mass. That will be the acceleration of the bottom block. Okay. What is the, okay, let's see, what is the acceleration? How to find the acceleration of the bottom block? Oh, no, you don't do that, sorry. You know the time taken. You know the time taken is 1 second. You know the initial velocity and the final velocity is, this is 6 meter per second and the initial velocity is 8 meter per second. So substitute the same formula, Vt is equal to ut plus At of the top block. Okay, this is bottom block completely. Bottom block. This is 8 and this is, this is, what is it? What is the calculated value? 6 meter per second is the final velocity, and this is 8. Plus you don't know A, but you know the time is just 1, with which you can find the acceleration of the second block. This is minus 2 is the acceleration of the second block. meter per second square. So once you find the acceleration of the second block, you can find the distance through which the bottom block has moved by using the formula ut plus half at square, because the acceleration is minus 2 and a half, and t square is just 1 square, and u is I think 8 in this case, right? 8, yeah, and t is 1. So 8 plus 1, 8 plus 1, no, this minus here, so 8 minus 1, so it's 7. 7 is the distance, 7 meters the distance done. So it's such an easy sum, but unless you understand how it's done, it's very difficult, okay? So புரிஞ்சிருத்துனா easy ஆயிடும். Okay, next to 10th sum. 10th sum is again the 1 kg block placed over a 2 kg block and moving over a smooth surface. Both of them are moving with 6 meter per second and 3 meter per second. In this sum, the coefficient of friction has not been given. When the relative motion between them will stop? Luckily the question is very simple. So initial momentum is equal to final momentum, P final is equal to P initial. Final momentum, both of them will move with the same velocity, and the total kg is 3 kg. Is equal to mass into respective velocity, which is 2 into 3 plus 1 into 6. Correct? So 3 2 is 6 plus 6 are 3v is equal to 12. 3v is equal to 12. So v is equal to 3v is equal to 12, v is equal to 4 meter per second. That's a common velocity, so the relative velocity between them will stop. I hope everybody understood these 5 sums.